Welcome to solverfy.
This is the answer to Chapter 15, problem number 68 from the Smith Organic Chemistry textbook. And this problem is asking us to show the two possible products from this allylic oxidation of 1-hexene with O2 to form the two possible hydroperoxides. And it is telling us to disregard stereoisomers. So there are only two possible products. And so, as the problem states, it is an allylic oxidation. And so the first product is pretty simple and straightforward. You just add the OOH because it is a hydroperoxide, and you just add it to the allylic position. There's only one allylic position in this molecule. To get the second possible product, you just transpose the double bond. So remember, in an allylic system, the double bond is much more free to move around. So if the double bond shifts over, the radical would be on the terminal carbon now, and so you would just add the OOH there instead. And so that's the answer to part A. Part B is asking for a mechanism. And so basically, the two possible products, they start from a common starting material. So the common first step is going to be that the hydrogen at the allylic position is abstracted by a molecule of O2. And so it's a free radical abstraction. So the hydrogen is gone, replaced by a radical. And then you have this allylic radical. And so the allylic radical can transpose or not. And so the left intermediate here is it not transposed, and then the right intermediate would be if it does transpose. And then whether or not it transposes, the next two steps are exactly the same. The O2 molecule and the radical will come together to form a new carbon-oxygen bond. So you'll then have the 1-hexene, or if it's transposed, 2-hexene, bound to this oxygen-oxygen. And so that's these two intermediates. And then the terminal oxygen there is just going to abstract a proton from somewhere else. In this case, the only other thing that we're told is in this reaction mixture is more 1-hexene. And so it'll grab the terminal proton from that starting material, and then that takes you to the hydroperoxide product. And so it's a pretty straightforward mechanism. In either case, it's only 3 steps. As always, I've drawn lone pairs of electrons and radical electrons and arrows to show electron movement in blue. And this is the answer to Chapter 15, problem number 68.